Feliz dia, which translates to happy day. Well, there's the sun playing peekaboo. I want to show you something that you're going to learn in the Algebra 2 class or higher math class. It is called fractional or rational exponents. It means the same thing. So here I'm showing you the formulas, and we are just using these letters, and you can see the letter I, the letter E, and the letter X. All of these letters are going to represent numbers. So when we have this, it will translate to the E stand for exponent. It will go on to the top. And the I stand for the word index. That's a number out here. And when there's no number, it's a 2. Assume when we have a square root. The index number, will be the denominator of these fractions. So here is the note on the top. It said converting between radical form and rational exponent form. Another name for it is fractional exponent form. In the next one, I will show you the exact same formulas, but in this place, we are using the letter X, the letter A, and the letter B instead. And all of these letters can be changed again to XYZ, any alphabet letter. We are just showing this to hold its place and show you that the B stand for the index this time, instead of calling the index in I. And then the exponent is called the letter A this time. And here's the exponent inside the radical symbol. So here is the square root or radical symbol. And then the X is called radicand. You can only change it in fraction form to the radical form or radical form to fraction form. It's only valid when we don't have a denominator of 0. And the problem down here, we said fractional exponent and radical. We have the letter Z with the fraction 5 over 3. So 3 is the indexed numbers, and you can see this 3 is on the outside. That's the index numbers. And then the 5 is the exponent. You can have it on the inside or on the outside. And we will show you another variation of these formulas. Of the same formulas, you can see we are using the different letters of the same exact formulas again. We are using the letter X is still used. We did not change that one, but the letter M or the letter N, like I mentioned, any alphabet letter can be used to represent any numbers here. And again, the N is the index and is still going to be in the same place. The index is out here. And when we don't have an index because of the name square root, that index number automatically become a 2. And then the exponent, you can have it on the inside under the radical, or you can have it on the outside of the parenthesis like this. As long as it's an exponent, see on the very outside of everything. And this is depending on the problem, whichever is convenient for us to simplify. We can have it under the radical or outside. We are going to do problem solving in the next part. This part here, you are seeing the animation of the index, and the exponent index B is going under in the denominator. The exponent is the letter A on the very top of the fraction. And this is only possible when we have a valid number, which is not going to be a 0 for the denominators. And this cannot be 0. So any number is okay as long as it's not a 0. Rational exponent or fractional exponent is another name for this part. We are showing you how to rewrite this into the rational exponent. Instead of fraction, fractional exponent, we're using the radical form, and then we will go ahead and show you how we simplify. First, I have the 2 for the denominator and the 1 on the very top. So this 1 is my exponent, this 2 is my square root, and I know it's a square root because of the 2 right here. What I would do is I would go ahead and draw the square root symbol. I may or may not put a 2 index here. If I don't put it there, it's automatically assumed because of this radical or square root, the name of itself. And leave the exponent of 1 right here. And 2 is automatic when we don't have this number, index numbers. So what are we doing? We are looking for the square root of 4, which is going to be, and for the sake of this one, I'll go ahead and leave the 2 index number outside here. The answer for this will be square root of 4 is just 2. And that's because 2 times 2 is 4. Same thing with the next one. 25, the exponent is 1 over 2. So I know that this 2 is again a radical or square root. And this time, I'm going to leave the index out on purpose. The 25 is again under the radical form. And the exponent can be on the inside or can be on the outside. It will not matter because the exponent of 1 will be itself. So I can have it in here, or I can have it an invisible 1. What is square root of 25? Yes, if you have 5, then you are correct because 5 times 5 is 25. Anytime we have a perfect square or a number multiply itself, we draw it out of the radical or square root sign. Again, 81 with the exponent of 1 over 2. What I would do is the 81, put it under the square root. 81, square root of 81 is 9 times 9, which is 9. So 9 is the answer for 81 with the exponent of 1 over 2, or square root of 81, which we rewrite right here. Can you pause and try and see if you can complete these last 2 problems? I started drawing the radical form because we are going to rewrite it in the radical form first. The 1 is the exponent. It can be on the inside under the radical, or it can be on the outside. The index is 3, and when it's not a 2, you must write it in. Okay, we don't have to write it when it's a 2. Like this denominator right here, I don't have to write it in like this first one, only when it's a 2. When it's any other number than 2, we must write it in, like the 3 right here. I'm putting it here. So what I'm looking for is a number multiply itself 3 times under the radical. Notice over here, we're looking for the number multiply itself 1 time only. So that's the perfect square. Here we're multiplying a number 3 times to be able to get out of the square root. Are there any number like that can multiply itself 3 times and get 8? Of the exponent of 1 so that it looks cleaner, we do have a number multiply itself 3 times, and that's how we can get out of this radical form. We can have 2 times 2 times 2 3 times. See, the index is telling you how many times this number under here multiply itself 3 times, then it's 3 times before you can leave the radical. If it's 4, then we need something that multiplies itself 4 times. And here I'm going to have the same 1 over 3 for exponent, and the number is 125 to the exponent of 1 over 3. Pause and try. The radicals started. We are going to have 125. Because of the exponent of 1, I don't have to write it in. I could put it, but it's going to be itself. And the number 3 must be written in because it's not a 2. We have to write the index number in, and this index tells you how many number under here multiply itself that many times to get out of the radical house right here. So do we have something multiply itself 3 times to get equal to 125? Yes, if you are thinking of 5, then you are right because 5 times 5 give me 25, and then 25 times 5 we will get 125. So the number 5 multiply itself 3 times, and remember the index number when it's written it tell you how many number multiply itself that many times to get out of the radical or square root symbol. You can see again the answer is written nicely over here. We also have one extra number which I did not show you earlier, 343 to the exponent of 1 over 3. We are going to still apply the same thing. 1 is the exponent, 3 is the index, a number multiply itself 3 times, and we have the answer of 7. This last problem here. And because you are so good, we are going to go ahead and show you one way to get extra credit. What you can do to get extra credit is, and this is the reward for everyone who listen all the way to the end of this video, and make sure you check and correct your answers. You are typing in on an open tab, so I'm just going to close that and open a new tab. In Google, I type IXL, fractional exponents, hit enter, and it will bring you to this one. If you can do the check for understanding on this one, when you're doing it correctly, you hit submit, and however many correct you get for the score here, you want to go ahead and take a screenshot at the end, and we will go ahead and give you that extra credit. You can only do up to 10 per day before it tell you to get membership, and the limit is 10 problem a day. So if you can go on another computer, you can try another 10 problem, or you can clear the history. But we don't want you to pay for membership to get extra credit, okay? You are just going to try, and the maximum point you can get is 10. You have to email or submit this to Miss Nong or show me during the class, and then we can give you the points. However, you will have to show me the time and the date when you take this screenshot. Make sure that you're taking the screenshot of the whole screen so I can see the time and the date, and we cannot copy from each other and get the extra credit. Follow direction, and I hope you have a happy day. Before I leave, I want to also go back to this one. These are slides that we went over. And we just want to point out this part right here. If you are using these letters, the E actually stand for exponent and the I stand for index. And you can see this red word right here is kind of hard to see, but it's an exponent over index, EOI. If you guys ever forget which one go first, well, it's alphabetical order. E on top, and then I, just like E is going to come up first in the alphabet letter, and then the letter I. Enjoy the day. Feliz dia.